couple of seconds of the light bulb. Hi, I'm Charles Emmons. I'm with JTech. Today I'm going to explain how electricity works, and I'm going to show you a simple circuit followed by Ohm's law. To my right, electricity is like water. It has pressure and it goes in wires to do work for us. I have here a tank, much like your battery. It holds an electric charge, it holds pressure, much like a tank of water. If you take a tank of water and you put it in a hose and you open the hose to a wheel and make the wheel turn using the water pressure to do work, that's exactly how electricity works. You have the pressure, which is volts, going along a current, going along a wire or a pipe. We call that current, and we measure it in amps. And this is resistance, is what anything that slows down the current or makes it do work. The wheel in this diagram is the work. It is resistance to current flow, right? And as the current flows, it spins the motor or the wheel, causing work. All right, and that is a relationship between volts, amps, and resistance. That's exactly how electricity works, just like that. Now, over here, we have the Ohm's law formula. You have volts over current, which in this case is an I. V is for volts, I is for current, R is for resistance. To put another way, V, and you have it like a division line, I times R. If you know two of these, you can get the third. In this basic circuit I've drawn, you have a battery, positive, negative. You know the battery is 12 volts like in your car. And you have a light bulb right here, which, going all the way to this diagram, would be the resistance or the work. It's a light bulb, and it is 2 ohms of resistance. That is when the current goes to the bulb. Now, using the formula, we're going to substitute the V to 12, which we know is 12 volts right here from the battery. Okay, and you know the resistance right here, which is 2 ohms symbol, right? And what we're trying to find out is the current. How much current is in this circuit right here? So 2 into 12 will go 6 times, and that's 6 amps of current in this system. Okay, because 2 into 12 is 6. And if you notice, like this circle, you take away one number and you can get the other, you still have 2 numbers, you can get the third number. If there was no 12 right here, you could use your resistance and your amps to find your voltage. 2 times 6 would be 12, of course. Right. And that's using Ohm's law formula to find amps, voltage, and resistance or ohms in a circuit. Okay? And remember that when you're talking about electricity, it's pretty easy. Volts is just like water. Current is the water going through a pipe. In this case, it would be wires like this circuit right here. And the resistance or the work would be like your bulb right here. That's it. Hi again. We're at the back of the vehicle where we're going to simulate a burned out bulb in the tail light. As a technician, if you have a problem with the brake lights or the turn signals, you would come back here and you do a visual inspection. Having found everything good, you would probably move to checking the actual circuit. That's what I'm going to do now. We have the blinker stalk on, is actually blinking, and I'm going to check both leads, and we should see power coming to our voltmeter. And this is going to verify that we have power coming back here to our light. As you can see, the voltmeter goes from OL, which is out of limits, to 9 volts, indicating that power is blinking just like it would as if a light bulb was in the socket. So you have voltage all the way to this socket. Next, we're going to check something called continuity. It is a simple test to make sure that the light bulb, you can use it to check light bulbs or different pins. It's going to check and see if there's a constant path for the electricity to follow. It's just a simple test. We're going to turn it to, if you can see on the voltmeter, the continuity check, which has like a little audible blue waveform on it. And once again, you're going to check your voltmeter. You're going to touch your leads, and you should hear a tone. That is continuity. Now, if you check your light bulbs and it makes that sound, that means your bulb is good. Check one right here. Okay, that tone indicates there is a path for the electricity to follow. It isn't a catch-all. There's one more test to do called the voltage drop, and it is to check for high resistance in the circuit. When performing a voltage drop, you have to have the voltmeter set in a DC volts setting, and what you're going to do is you take your 2 leads and you're going to check along the same wire in a circuit. In this case, I'm going to check the battery ground, and I'm going to simulate a bad ground and a good ground to show you the difference between voltage drop. Normally, you want to use all the voltage you have in a circuit to power your accessories, your motors, your bulbs. When you have high resistance doing a voltage drop, it means that power is not moving. It's just sitting there. There's a bad connection or an open circuit. And that's what a voltage drop will tell you in a circuit, a basic circuit. We have a battery here. We have a negative side of the battery. We have a post and a terminal. I'm going to use both my leads, and I'm going to use it on the negative side, and we're going to see a good voltage drop, meaning that the current is moving is below 0.5 volts. Anything below 0.5 volts. And with this negative terminal, the voltage is 0.001 volts. Make sure that in a auto ranging multimeter that you have it on volts and that it doesn't skip to millivolts or some other measurement. Make sure it's on volts. Now, that's a voltage drop in a circuit. I'm going to take the negative post off and set it to the side, simulating an open circuit. Now, if you're doing a voltage drop and you have an open, the multimeter is going to go to OL, out of limits. Now watch the multimeter, if I can get it to point towards you, sideways. Now watch the decimal points as I take it and gently touch the negative terminal to the post. You're going to see a spike in voltage. See the 0.7, 1.0, 0.8. That is simulating a loose connection in a circuit. Remember, a good voltage drop is going to be below 0.5 volts. Now I'm going to put the post back on securely on the post terminal, and we're back to our 0.001 volts. And that is how to do a voltage drops test in a circuit. And it doesn't matter if it's a battery post or further down the same circuit. You can test a starter circuit this way or a light circuit this way. It's always the same two leads on down, point to point, until you find the short or the open on a circuit. Thank you. V right here for DC current, volts current. Okay, and I'm going to put one lead on a positive, one lead on a negative, and we should see on the multimeter, if you could look at the multimeter, should say we have 12.5 volts in this battery. A good battery is anything 12.6 volts. That's a good battery, but at least it's telling us the voltmeter is good. It is working. Now, to check voltage on any circuit, the circuit has to be live. You have to put power on the circuit. In the instance of this blinker, we're going to cut the blinker on. If you were checking your horn, you would have to hit the horn if you're checking the horn circuit. Checking the brake circuit, you would have to hit the brakes. Voltage has to be running. All right, go ahead and cut it.